Dr. Sujia, Assistant Professor in the Department of Computer Application at Dr. SNS Rajalakshmi College of Arts and Science. Today, the lecture video I am going to discuss is about flip-flops. Flip-flops is a basic digital memory unit which has two states, that is logic 1 and logic 0, and based on these states and the logic unit keeps on changing based on the clock, and it is a sequential circuit that consists of a single binary state of information, and this is also called as bistable multivibrant. And so this is all about the flip-flop interaction. And when we discuss about the types of flip-flop, we have totally four flip-flops which will be discussed in the oncoming slides in detail with the truth table and with along with the circuits. So SR flip-flop is helps for presetting and clearing the circuit when the switch of the power is on and off. And here we take two logic, that is set Q is equal to 1 and reset Q dash is equal to 0. And this is used in many applications for setting and resetting of the flip-flop in the initial state when a task is assigned. So this diagram is the flow of SR flip-flop. We have a clock. So based on this clock, the reset and the set value keeps on changing, which finally produces a value of Q and Q dash, considering with high and low, where we finally get the value of preset and clear. So this is the circuit diagram of an SR flip-flop. So totally we use four logic circuits for generating. So once a clock has been enabled, the set and resets keeps on changing, which produces a value of Q and Q dash. So this is how the truth table works on this particular concept based on the values of SR and reset. For example, if set is 0 and reset is 0, then the value of Q and Q dash will be 0 and 0. It will be on the stable condition. So it is clearly explained here. So the case 1, if reset and clear is equal to 1, it is said that the clock input is in the normal form. And if the case preset is 0 and clear is 1, then it is said that Q is set to 1. And if the case if preset is 1 and clear is equal to 0, then Q dash is set to 1. And in case of 4, if preset and clear is equal to 0, it is said to be in an ideal state or an invalid state. So this is how an SR flip-flop works based on the input of the preset and clock based on the clock changes. So this is all about SR flip-flop. Next is J flip-flop, another part of the flip-flop. Here this J flip-flop consists of clock, clear and reset. So based on the clock, this clear and resets works. So this is also as like of an SR flip-flop, the clock will be keep on changing, and based on the clock change, the preset and clear values will be changing from 0 to 1 and 1 to 0, and finally we get the value of Q and Q dash. So this is all about a JK flip-flop, and this is the circuit diagram of JK flip-flop. It is also similar to that of SR flip-flop. We totally have four NAND gate, and based on this NAND gate, the clock will get active, and finally we get the values of Q and Q dash. So this is the operations of JK flip-flop. In case 1, if both the conditions are 0, it is said to be an invalid state. And in case of 2, if both the conditions is, that is the preset is 0 and the clear is 1, it is said that the flip-flop is in the set state and Q will be set to 1. And in case 3, if the preset is equal to 1 and clock is equal to 0, the clock gets activated and the Q dash will be set to 1. And finally, this is said to be in the reset state. And in case 4, if the preset and clear is equal to 1, then the condition is said to be normal, and the P and CLR has to be get deactivated from the active state. And this is the operations of JK flip-flop. Next is the D flip-flop. A D flip-flop consists of a data input D and the clock input CLK and the two outputs Q and Q dash. So in the previous JK flip-flop and SR flip-flop, we have taken two inputs. So based on this preset and set only, the clock may vary, and finally we get Q and Q dash. But in case of D flip-flop, only one data input is being taken, and based on the clock changes, we'll be getting the values of Q and Q dash. Q dash is the complement of Q. So this is all about the D flip-flop. So this is the circuit diagram. Here in this circuit diagram, as we consider only one input, the another NOT gate has been taken, and we have taken four and NAND gate, and finally on this clock changes, the Q and Q dash will be gets operated. So this is the operations of D flip-flop based on the preset and clear. So the D flip-flop varies from active state to inactive state, and which output has to be set to 1 and which output has to be set to 0. So this will be taken place in the based on the operations of the D flip-flop. Next we are going to see is about the T flip-flop. T flip-flop consists of a data input T with the clock CLK and 2 outputs. So this is also works similar to that of a D flip-flop. So the D and the T flip-flops works on one data input, whereas the other SR and JK flip-flop works on 2 input. And so this is the diagram where preset and clear works on the clock and based on the data input T. So this is the logic circuit where we have 4 NAND gates. So based on the changes of T and clock changes, we'll get the output of Q and Q dash based on the values which has been assigned to T. So this is the operations of T flip-flop. Based on this, two cases will be operated. When T is equal to 0, the Q will remain unchanged. Where T is equal to 1, then the Q will be a complementary state, so where Q dash will be 1. So this is all about the flip-flops.